Hello and welcome to ISU Media Message. I'm Bob Lindemeyer, Associate Director of the Media Resources Center here at Iowa State. And the purpose of our program is really quite simple and straightforward. We're giving our television audience, you folks out there, an opportunity to view some of the fine films and videotapes that we've produced and haven't previously been seen by the television audience. These programs are usually seen here at the university, seen in classes, and not seen by the television audience. My guest today is Jeanette Bonenkamp, Associate Professor of Food Nutrition, and you have a new title in the department now. Give me the whole...
Yes, our department is now the Food Science and Human Nutrition.
Okay. And you made a series of 4 videotapes, right?
That's right.
We're going to get a chance to look at a couple of them tonight. They're in a series you call Food Preparation. Dealing with what? Basic
techniques. These are things that we used to do as live demonstrations. We did them 6 or 8 times a semester for each one. If we had a bulk section of 18 people, we had just a few who were down in front and who could see what we were doing, and the rest of them were standing out there.
So the tape really helps, doesn't it?
That's right.
Let's look at the first one. It's entitled Measurement from the Food Preparation Series.
In this videotape, we'll demonstrate common measuring techniques that are appropriate for both food preparation laboratories and for most home use in the United States. Nested dry measuring cups are used for dry ingredients so that they can be leveled on the top with any straight edge such as a spatula. Measuring spoons may also be leveled in the same way. In order for the measurements to be accurate, the cups and spoons must be in the original shape and free from dents. Typical cup measurements are 1/4 cup, 1/3 cup, 1/2 cup, and 1 cup. Measuring spoon sets include 1/4 teaspoon, 1/2 teaspoon, 1 teaspoon, and 1 tablespoon. It's difficult to get an accurate volume measurement for dry ingredients that pack, such as confectioner's sugar or flour. When standard recipes are developed in the United States, the flour is measured by sifting it. Carefully spooning it into the dry measuring cup without packing, and then leveling. This method must be followed in the laboratory or kitchen in order to measure the amount of ingredient intended by the recipe developer. It's not necessary to sift flour for recipes where a precise measurement is not required, such as for thickening. Whole grain flours don't lend themselves well to sifting, so they should be fluffed with a fork before measuring. When measuring flour, people often unwittingly shake the cup to level it, thus packing the cup. If the side of a properly measured cup of flour is tapped, one can see how easily flour can be packed and the measurements made inaccurate. There are some ingredients, such as brown sugar, that should be packed. Brown sugar should be packed enough so that it will hold the shape of the container when it is turned out. Other ingredients that should be packed include chopped vegetables and grated cheese. However, for cheese, volume is very inaccurate compared with weight, and so weights are used in the food preparation laboratory. Volume measurements are often accurate enough for home use, but even then, an estimate based on package weight is probably more accurate than is volume. The equivalent volume to weight for cheese is 1 cup to 4 ounces or 114 grams. Packing is required to attain this weight. Liquid measuring cups are designed to hold more than the amount to be measured. This design makes it much easier to prevent spilling when transferring the liquid to the mixing bowl. The cup should be on a level surface and filled to the bottom of the meniscus. The size of the measuring cup should be close to the amount being measured for greatest accuracy. Some very thick ingredients may be measured in either liquid or dry cups because they do not spill easily. One must be careful not to fill beyond the top of the container. The excess that can be mounded beyond the top is enough to make major proportion changes in some recipes. With any measurement, be sure to remove all the ingredient from the utensil. Whenever you measure ingredients, always be careful that you don't do it over a container of other ingredients, because any spillage will become part of the mixture. Some recipes in laboratory manuals have measurements that are smaller than typical home recipes. To measure 1/8 of a teaspoon, for example, level a 1/4 teaspoon measure, cut it in half lengthwise, and remove half. For a 1/16 of a teaspoon, repeat this process and cut crosswise as well. Shortening is usually measured in dry measuring cups. Be sure that it is packed so that there are no air pockets in the cup. If butter or margarine is in a stick form with measurements on the side of the package, these measurements can be used for most products. Be sure that the wrapper is put on the stick correctly. You can see here that the printed measurements would be inaccurate. If shortening is very hard and it is difficult to pack into a cup, water displacement may be used. In this case, a liquid measuring cup is used and water is added to make up the difference between the shortening measurement and the capacity of the cup. For example, to measure 1/3 of a cup of shortening, first measure 2/3 of a cup of water, and then add shortening until the total amount in the container is 1 cup. Eggs are usually counted rather than measured. However, if the measurement of egg or egg white is critical to the success of the recipe, such as in soufflés or angel cakes, it is measured. A large egg equals approximately 1/4 cup. If a laboratory manual recipe calls for 1/2 egg, use 2 tablespoons of blended whole egg. The egg should be blended so that the half egg will have the right proportions of yolk and white with no air beaten in. It may be easier to pour egg into a measuring spoon than to dip the spoon into the egg. For accurate measurements, use the fewest measurements possible. If a recipe calls for 5 tablespoons, for example, measure 1/4 cup and 1 tablespoon. If a recipe calls for 3 teaspoons, measure 1 tablespoon.
have it. The first in the food preparation series, and it was entitled Measurement. Janet, do we really need to be that careful with the way we measure things? I remember that little meniscus business there. I mean, how about these French chefs that just throw in a dash of this and a pile of that?
They've made a lot of them.
Yeah.
They can probably eyeball it, but it depends on the recipe. Depends how important the proportions are. But in class, we're working with very small amounts, and very often we have a controlled experiment. We want the difference between a product made with one ingredient and another one with a slightly different one to be very well controlled. But you can never make a mistake by being too accurate.
I guess that's true, isn't it? These tapes are seen by a laboratory class in food preparation.
Yeah. We use them for our undergraduate food preparation classes,
Right.
but they focus on technique, and they have rather than theory, and so they really could be used at any level. The material that's in these would be appropriate for a 4-H group, all the way through to college classes where we're using them, or adult groups.
Okay, now I think the tapes are actually in circulation through a national distributor.
Yes, they are.
Chip Taylor Communications has them available, so we can give Jen a little plug there for the tapes. There's actually 4 in the series, right?
That's right.
And the next one we're going to see is about pastry and pie crust.
That's right.
Now that's tough to make, isn't it?
Can be.
I think today, don't most folks buy them in the frozen food section? Pie crust?
I suppose that's probably true. Yes.
Well, if you want to bake a cherry pie and do it the right way, let's take a look at the second in the series from the food preparation series by my guest, Janet Bonenkamp. This one is titled Pastry and Pie.
This videotape will illustrate the preparation of pastry for 1 and 2 crust pies. These are the ingredients for a 1 crust 9-inch pie. 1 cup of sifted flour, 1/2 teaspoon of salt, 1/4 cup of lard or 1/3 cup of vegetable shortening, and 2 tablespoons of very cold water. For a 2 crust 9-inch pie, these ingredients are doubled. Notice that the measurement for shortening depends upon the choice of shortening. Because lard has more shortening power than an equivalent volume of vegetable shortening, a smaller amount is needed. Begin by preheating the oven according to recipe directions. This recipe follows the steps of the basic biscuit or pastry method. 1. Blend the dry ingredients. 2. Cut in the solid shortening. And 3. Add the liquid ingredients and manipulate to develop the appropriate amount of gluten. First, stir the salt into the sifted flour. Next, add the shortening and cut it into the dry ingredients with a pastry blender. A fork or 2 knives will do if a pastry blender is not available. The fat should not be allowed to melt because when the pastry is rolled, the solid fat particles form thin layers that separate the flakes in the baked pastry. Cut in the shortening until the fat particles are the size described in the recipe. For a plain pie crust, 2 descriptions of the appearance are commonly used: the size of small peas, or until the mixture looks like coarse cornmeal. Larger particles will produce larger, more distinct flakes in the baked pastry. Smaller particles will produce many smaller flakes. The smaller the particles, the more the shortening spreads over the flour, and consequently, the pastry is more tender. Distribute the water evenly throughout the mixture. Toss rather than stir the flour as you add the water. Use cold water because it is not absorbed as quickly as warmer water. This makes it easier to distribute evenly, and it helps keep the fat solid. Push the moistened particles off to the side so that the remaining water can be added to the drier portion of the mixture. The pie crust recipe used for this demonstration has less water than many recipes. Therefore, it can take more manipulation without excessive gluten development and consequent toughness. Manipulate to develop enough gluten so that the dough can be shaped into a ball and flakes can be formed. Pat the dough into a ball and flatten it with your hands. Next, spread a small amount of flour on the board and also on the rolling pin. Then roll from the center towards the edge, letting up on the pressure as you come near the edge to keep the thickness even. Keep the shape round. If the dough becomes difficult to roll because it is sticking to the board, it may be necessary to add more flour. With a spatula, carefully lift the dough, being careful not to stretch it as you spread more flour on the board. Roll the crust until it is 1/8 inch thick or less and extends 1 inch beyond the edge of the pan. Only a slight dent should remain when your finger is pressed into the dough. Fold the pie crust very carefully. Then lift it into the pan, centering it so that it will be correctly placed when unfolded. Carefully fit the pastry into the angle between the side and bottom of the pan without stretching. You should be able to see the shape of the pan through the crust. This is a single crust pie shell for a meringue pie or a chiffon pie. It will be baked before the filling is added. To prepare the crust for baking, the edge is cut with an overhang of 1/4 to 1/2 inch. The edge is fluted, and the pie is pierced with a table fork every 1/2 inch. This allows the steam to escape and prevents bubbles from filling the shell. This is the bottom crust of a double crust pie, so the crust is cut even with the edge of the pan. The top crust is rolled the same as the bottom, extending 1 inch beyond the edge of the pan. Vents are made in the top crust to allow steam to escape during baking. If the pie is to be frozen before it is baked, the vents may be made just before baking to avoid spillage of fruit filling. When the top crust is ready to be placed on the pie, put the filling in the shell. If the filling is put in before the top crust is ready, it is likely to soak in, giving the baked pie a moist bottom crust. Moisten the edge of the bottom crust with water. Place the top crust on the pie. Press gently around the edge. Cut the top crust to about 1/2 inch overhang. Tuck the top crust under the bottom. Flute the edge by crimping all 3 layers, 2 top and 1 bottom, with your fingers. The fluted edge should seal the 2 crusts, give some protection from filling overflow, and give an attractive finished edge to the pie. Bake the pie immediately to prevent the filling from soaking into the bottom crust. These are the signs of a high-quality pie. A golden brown crust is the test for doneness in a single crust pie. The slightly blistered surface is an indicator of a flaky pastry. The flakiness is illustrated by thin layers of baked dough. Good flavor is dependent upon good quality ingredients and proper baking. The pie crust should be crisp, dry, and tender. The delicate flavor is influenced by the type of fat used. There are several additional characteristics of a high-quality double crust pie. The filling should be contained generally within the pie shell. It is acceptable for a small amount of filling to cook out of the vents, but none should cook over the edge. Fruit pieces should be plump, moist, and intact. The filling should have thickened, but should flow slightly when cut. There should be little or no soaking of the bottom crust. The fruit pieces should be soft and tender, and the cooked flavor should be appropriate for the type of fruit. The pathway to the perfect pie has many pitfalls, however. Deficiencies in technique will be evident when the dough is formed and rolled. Some of the most common mistakes are illustrated here. This information should enable beginning pastry makers to diagnose most of their difficulties and to improve their technique. For example, if the fat has been cut in excessively, or if it has melted, the dough will be too tender and mealy. It may be difficult to tell how small the fat particles are because the flour may clump, giving the appearance of progressively larger rather than smaller particles. The dough may look moist or greasy. When the water is added, the dough may look moist because the water will not be absorbed as thoroughly as it should be. The dough will not roll to a round, smooth edge. It may have a translucent look, and it will tear very easily. It will be difficult to shape into the pie plate, and the edge will be hard to flute. The crust may be too tender to hold its shape when the pie is served. On the other hand, if the fat has not been cut in enough, the flour will absorb the water very quickly. The dough will seem too dry to roll, but if more water is added, the pastry may become tough. This occurs because the fat has not been distributed well enough to tenderize the dough. Extra water also encourages excessive gluten development. Wet white streaks may appear on the surface of the rolled dough if the water has not been distributed evenly, or if the dough has not been stirred enough. When the pie is baked, the streaks may be tough and the remaining crust dry and crumbly. Sometimes a dough may be easy to roll to a round, smooth-edged circle, but it will be quite elastic. This is a sign of excessive gluten development. This is caused by excess water or too much stirring after the water was added. The baked pie crust will be tough, and it will probably shrink away from the edge of the pan. It may not brown as quickly as a standard crust. These are some of the most common mistakes made by novice pastry makers. All of them are related to how well the baker follows the steps of the basic biscuit or pastry method. 1. Blend the dry ingredients. 2. Cut in the solid shortening. And 3. Add the liquid and manipulate to develop the proper amount of gluten.
pastry and pie crusts. What could be easier? Janet, you must have made a lot of mistakes in order to get that one photographed, didn't you? You had all sorts of disasters as well as successes.
Well, some of them were intentional and some of them weren't.
Okay. You have to demonstrate how to do it well and how to do it wrong, I guess.
That's
as well.
right. Well, those are things, common mistakes that we see in class, and we try to head them off by showing them why they occur.
What are the other two titles in the series now, in case our audience wants to get a chance to see them? You did.
There's one on the muffin method that shows muffins and some cakes, and there's one on the biscuit method that shows standard baking powder biscuits.
Biscuits, okay. And I think from my own experience, you can also make lots of mistakes with biscuits.
Yes, you can.
They come out hard as rocks or lumpy
Or misshapen. That's right.
All right, so what's next? Are you going to do some more tapes with us soon?
Well, I don't know. We may, because we have found that these have been very helpful, and we may continue this series.
Good. Well, it's been our pleasure to have you here tonight. I want to thank Janet Bohnenkamp for being my guest. We've been watching her series called Food Preparation, and I hope you'll join us here next week for another chapter in the ISU Media Message.